Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic and, when there's not a global pandemic, on location. Each time we meet, we bring together a group of IT luminaries to discuss a single concept or premise. In this episode, we're discussing the end times. That's right, the end of computers as we know it. But before we begin, let's quickly meet who's on the panel today.
I'm Denny Cherry, from Denny Cherry and Associates Consulting. You can find me on Twitter at Mr. Denny. You can find me on the internet at www.dcac.com.
Hi, I'm John Obeto. I am a head bottle washer at LogicWorks. We're a managed service provider. I'm on Twitter at 2Obeto, 2, the number 2, and Obeto, hard T. And I'm on the internet at absolutelyjohn.com.
Hi, I'm Jason Collier. You can find me on Twitter at Bocanuts. I'm currently an analyst over at GigaOM, and I've spent the last 25 years doing tech startup companies in Silicon Valley and Austin.
So today we're discussing the fact that computers seem to be exploding. And I don't mean literally exploding. I mean the fact that if you look at how enterprise technology works, if you look at the state of enterprise applications, since like the big data explosion of, a decade ago, basically everything's growing beyond the computer. If I said, hey, I want to have a startup and we're going to index the entire internet. If step one was buy a really big server, you'd just laugh me out of the room, right? I mean, everything these days is way bigger than a server. And it seems like increasingly the kind of technologies that are being, delivered, whether it's from, CPUs like companies from Intel and AMD and ARM, or whether it's interconnects, whether it's, data, whether application monitoring, everything is growing beyond the computer. And it seems like we've reached the end. We've reached the end of relevance for the computer. I'm going to start this off by asking Jason, because I know that you've worked at a company that was developing basically bigger than a computer software. Is this what you're seeing, that it's the end of the server?
Yeah, absolutely. I mean, one of the things that, we had kind of had on, kind of the long-term roadmap is, even what if you could build a virtual machine that's bigger than any physical constraints of any specific machine, right? And I think it's going that way with composability. Now, another funny thing that you mentioned was, if I'm going to buy a computer to search the internet, and I remember specifically in 1995, I actually knew that the guys over at Alta Vista, they had the same financial backers as we did at our startup back then. But Alta Vista was literally proving the power of the DEC Alpha chip, because they literally could have one server where they indexed the entire internet. Of course, it was 1995. So guess what? It was a little bit smaller back then. But as it grew through the, the generations of the, kind of the original .com to where we are today, no specific application, no application in general, like runs on a single machine, right? Everything is distributed, but I see that going more and more from actually the disaggregation of the compute components within servers themselves, and having the ability to, basically address things outside of, the physical realms of possibility.
That's a very good point. I also see it, if you look at it from a physical standpoint, right? The CPU, something that Jason just touched on right now. The CPUs are going to get to a stage where they'll become very relevant, because there's so many other compute components, right, that are taking slices of what a CPU you really used to do back in the day, and they're actually bringing value to making it work for a specific application or for a specific use at that time. I think the Apple M1 chip sort of is showing the way out there, where you have this chip that's by all indications should be vastly underpowered, right? Trouncing everything in its path and being the best chips, because it's highly specialized, it's purpose-built, and everybody now seems to want to go that way. If you look at, as we understand it, Microsoft wants to do that with Azure, Google's doing it. Everybody wants to make sure that they're not just dependent on the CPU to do that. And with that goes the server, because the server is always the big CPU, the Xeon, right?
Yeah, one of the things I think is really going to be interesting and really going to change things over the next few years is going to be how this massive growth of distributed computing ends up happening. We're seeing a lot of much smaller applications really hitting the end of their scale, or at least I have. and they can't be scaled up anymore. And we have to go back to the developers and back to the architects and go, hey, cool. So you now need to be able to support this running on 10 different nodes at once. How do you scale this out? You know, how do you have to redesign everything that you've been doing for the last 20 years so that you can make it so that things can scale across all these various machines? Because these machines aren't getting any more powerful. And so we need to be able to scale the broad width of the world now. And on top of that, we need to be able to build in basically time lag as stuff needs to be able to scale across the world. Because you may have users in Los Angeles, users in London, and users in Mumbai. And they all need to be able to see the same application. How is your app going to scale across that entire world, especially given the fact that there's 100 millisecond lag between all those various places? Because we need to be able to deal with this whole problem of fiber. We can only move light so fast from point A to point B, and so because of that, we have internet lag. And so how people need to start thinking about how they're going to address that as they're building these really dynamic applications and scaling these things out. And how do we deal with this, and how do we process all this stuff?
That's a really good point, Denny. I mean, one of the things that I always used to say in one of my talks was when microseconds matter, the cloud's only 88 milliseconds away, right? And it's one of those things from a computational perspective, and you see this a lot, deployed on edge compute, where you're moving the computational decisions as close to the data where that decision needs to be made, right? And it really does comes down to those latencies, where best is it to make that decision? An example of this, if you've got, a car like a Tesla that's got autopilot on it, guess what? You probably don't want it making a decision on whether or not it should brake or apply the auto brake or swerve out of the lane to avoid getting hit. You probably don't want that being made in the cloud. At this point, especially if you got lousy cell coverage where you're driving. And another way, I think when you see this, like computing moving closer to, the data on which it needs to act, things like computational storage is another prime example where you're actually embedding, CPUs on storage devices. And, there a lot of the CPU makers now are even putting, kind of these high speed lanes in to where you can get access to FPGAs or getting access to, like what we've seen, with Optane and PMEM, being able to get, closer access and closer to the CPU access of these additional computational devices. John, what you said about M1 is a prime example. And, Apple does a really good job of advertising, look, hey, it's not just the CPU anymore. We've got this neural net processor. We've got, graphics chips. We've got all this stuff where, the closer, the tighter we integrate that stuff, the more computational power we can have, within the system, but also more importantly, without, outside of the system, going back to the, scaling out, not scaling up as the real vector for scalability now.
Yeah, I think you nailed one thing here, and I don't even know if you nailed on it, was talk about the edge and being able to put more things out on the edge and doing more processing out on the edge. And this is absolutely the case. And where things are going to have to go is things are going to have to get processed out on the edge, because we only want the bandwidth. We're only going to have the bandwidth to send up what we need to send up. Whereas a lot of the times in the past, it's been, let's just send everything and we'll deal with it at the data center. Well, we no longer have that option. So I was talking to one company a while back, and they were monitoring spin bicycles at Spin Studios, and their original design was to send everything from the bike. Well, the bikes are now no longer, or they were before pre-pandemic, they were no longer, 3 bikes in the studio. It's now 40 or 50 bikes in the studio. And so taking measurements off those bikes every 5 seconds times 40 bikes suddenly no longer works, because when the studio's got, a basic cable modem. So you have to do a lot of pre-processing over there at the edge before you can actually send stuff up to the main data center to actually store that information.
When you're talking about the edge and all that data, I think of a phrase I call data uselessness, right? There's so much extraneous data that you just have to, I'm out there and I'm going back to deepest, darkest, Stephen, with my machete, right? And I'm just hearing all that stuff. We don't need this stuff, right? Because a lot of it is just, like you said, if you have those 40 bikes, most of the information there really doesn't need to be uploaded to the cloud. It doesn't make any sense anymore. You need the data that's going to be valid to either improve the product or data that you can monetize. You don't want to know that the bike's just laying out there, or, some guy's doing it at 2 miles an hour, whatever. You need data that can actually bring value to your enterprise. And coming closer down to each, we used to call it back in the operational unit, organizational unit, or whatever that business unit is, lets you take the data that's useful at that level, right, and push that out to where, to the cloud, to the data center, where the data guys can actually make it actionable and make business decisions based on it. But another thing I look at when we think about this is, we've talked about latency. I'm thinking of management overhead, and I'm also thinking about security, because all of a sudden we're running into problems. I mean, I tweeted yesterday about some guy hacked into a water processing plant and just screwing around, just walking around, and took away safety measures. I mean, we need to secure this thing. So unfortunately it was Windows. So damn. I know, right? I'm like, no, please don't let it be Windows. But yeah, it was Windows. And they got it through TeamViewer. I mean, God. So security comes into it, and that's something else I think we're going to have to look at. But I don't know. What do you think?
I totally agree. I mean, security is one of those big aspects of it. And then, kind of getting back to that data that you need. I had a specific edge deployment that we had deployed at my last company, and it was in a grocery store chain, right? And here's the thing, they had like 7,000 grocery stores, right? So, and then one of those edge use cases was they had about probably 130 refrigeration units in each one of those stores. And if it's basically pulling that thing, each one of those 130, each times individually, like every second, that's a lot of extraneous data that you don't need, right? So it came down to like the application that was designed where data was processed at the edge. It only really reported the anomalous data up through, into the cloud, right? It's because nobody cares if the refrigerator is working correctly. Nobody cares, right? That's good. That's how it's supposed to do it. You want to know if something has gone wrong, right? And so they really, developed the application around monitoring that, because, you think, oh yeah, 130, that's not too bad. Now you take 130 over 7,000 different stores. Now you got a different scale that you're dealing with.
Yeah, and this is one of those things that comes into the Utilizing AI podcast that I do as well. This idea that, it sounds counterintuitive, but, AI processing has basically increased the amount of data in order to decrease the amount of data. And it sounds weird, but that's actually what's going on. So whereas it used to be that we would have sort of hard-coded rules, like let's say like an edge device, right? We would have hard-coded rules that would say only send things above severity 4 into, to escalate, and throw everything else out in the trash. Now with AI at the edge, what we're doing is we're saying, let me see everything above severity 2, let the AI system process those things and escalate what it thinks need to be escalated to the cloud, and then deal with those things. And that's a very different situation. And what the output is essentially we're using a lot more data, but there's actually less data traversing the network. And this kind of goes to some of the things that we're talking about, like what Denny was talking about having data in multiple locations. You're talking about latency over the internet, Jason. All that stuff is kind of like just-in-time data in a way, right? It's like just-in-time manufacturing, just-in-time data. And it seems to me, though, just to kind of bring this back to the end of the server, it seems to me that we're scaling basically everything. So we have like multiple CPU cores, like many cores in a CPU. We have many lanes of IO within the server. We have multiple CPUs working together, multiple servers working together, multiple servers within a rack working together. So we've got rack scale architecture. We've got multiple racks, data center scale infrastructure. We're scaling outside the data center. We're scaling across the internet. We're scaling everywhere. And we're even scaling to the edge. So it seems like the entire compute environment, every element, right down to the CPU core, is scaled. In fact, even the cores themselves are scaled because we've got hyperthreading, right? So you're running more than one thread on a core. Everything's scaling, right?
Yep, that's and that's kind of the way it's had to go that way, right? I mean, the tremendous growth of the internet. Like I said, back in 1995, you could run it all on like one server. I was showing like, look how beefy this alpha server is. Yeah, and then guess what? I went back to the guys at Digital back in, like, I think it was like 96, 97, and that one server went to basically 4 rows of 40 racks that were doing it because of the scale. Guess what? It could do it in 1995, and in like 1997, a short 2 years later, it couldn't be done. So they were already scaling it out then, right? And everything has to be scale out to keep up with what it is. Now, the real important thing though is application developers have to keep up with the scale out trends, right? We don't write applications like we did in 1995, thank goodness. Even though there's still certain applications that always float around, they're still running, single thread and can only, access a specific amount of RAM. But, really honestly, the application development and deployment. Another thing you got to think about, scale out, it's great, solves a lot of problems, but also one of the problems that it really creates is, now how do you deploy an application across thousands of machines that are globally distributed, right? Now it's a different animal. And so it solves a lot of problems and it creates a lot more. So it's interesting how this ecosystem of kind of, the hardware operating environments all tend to scale, and then how that is then answered by the application developments going on in the space as well.
Yeah, the whole process of deployment is a whole new bear that a lot of companies and a lot of people are just starting to realize is something they need to actually look at, because you can't just drag and drop, copy and paste like you did 20 years ago, and voila, it's magically deployed. That doesn't work when you need to deploy to 100 or 1,000 machines. So you actually have to have some sort of automation process in place. And this is, I know I'm from not an IT background, but I'm from an administration background. And the whole idea of writing code is a foreign concept to me, basically, up until like 4 or 5 years ago, because we had to suddenly start writing code to deploy and manage at large scale, which we never had to really deal with before. It was always this siloed little, I'm going to manage to look at this one box. And now I need to look at 100 boxes all at the same time because they're all running the same thing. So how do I automate a lot of this? How do I manage all this distributed architecture and distributed systems? This wasn't a thing 10 years ago. Just wasn't.
You also have to look at I guess expectations, right? Service expectations from the deployed servers. I mean, if you're in the US, you fully expect almost instantaneous what's what I'm looking for, service from any product you're using. If you're in Burkina Faso, you know it's coming over on a slow boat, right? So you sort of expect that as well. So your data, your services have to be dynamic enough to recognize whatever location you are geographically or whatever the local prevailing service conditions are in order to have that service put out there. Plus, you also have to think about the security of not just the data, of not just your physical plant, but also the compute. And right now, I think that's with distributed services going back and forth, that's something that we're going to have to look at a very, very close rate when you're deploying outside of relatively secure environments where you know physically somebody can come in and yank whatever's out there, and all of a sudden you're prone to a hack. I mean, or look at SolarWinds, where they did that in the supply chain and introduced malware into it. That's something else we also have to watch for, I think.
Yeah, I think one of the other interesting kind of an intriguing areas where we're starting to see some, companies really come out and start to shine, that's also kind of, going toward this scale out trend in general, are the composable infrastructure style companies. And composability is getting to a piece now where, used to, if you needed like GPU compute, you would basically throw some, a couple of GPU cards into, a 2U server. And then, but what became of it was, it wasn't dynamically reconfigurable. You couldn't do a lot of things with it. And now we're starting to see that, where you can get these, PCI switch aggregation units and things like that, where you can say, oh, I got an application where I need to do neural net training. I don't want to use these Tesla GPUs to be able to do that. Okay, well, that's great. How do you pull off this without going to 3 weeks of hardware reconfig to do it? And, there are companies that are starting to come out now that are actually being able to do that, where you've got the capability of saying, oh, I want to boot this up and I want to give this access to 20 different GPUs, even though it's a 2U server, right? Going out and being able to create then an application kind of on demand, and then just tear it down and build up another one, and keep using those same resources, but in a very dynamically reallocatable way. That's another area where, it's really, with this composable infrastructure, you're starting to see, kind of some of these really unique uses for it that I think are going to be the standard way that we do data center deployments, in the next, over the next 5 years.
Yeah, it does seem to be that's the direction that things are heading. We've just seen here in the last couple of weeks the AMD third generation, the EPYC, as John mentioned, CPUs. We've seen now the Xeon Scalable third generation CPU launch. We are going to be hearing at the upcoming Tech Field Day event here in April. At the end of April, we're going to be hearing from Micron talking about CXL. We're going to hear about Xilinx talking about DPUs. A lot of this stuff is really oriented toward exploding the server, and not only that, but as you were saying, Jason, earlier, having the server be a lot more than just a box that has CPUs in it. Having the server be a box that has lots of different specialist processors and connecting to other specialist boxes. And, I guess that's the new server architecture, right? It's going to be something that's massive and scalable.
Without a doubt. And I think it's almost a greenfield right now. If you look at companies like you mentioned, Xilinx, you mentioned the DPUs, you mentioned Micron. All of a sudden, they can take, if they want, an ARM product, right? And so customize that it becomes theirs, right? And if Intel's not careful, probably in the next few years, right, create their own server chips that can actually create a function, right, where they can then sell that as a composable piece of, of some architecture that some user might want in the future, I think.
Yeah, the industry is getting pretty interesting as well. I mean, there's more, like even NVIDIA, who you traditionally think of as, the GPU provider. Well, if you look at a lot of the acquisitions NVIDIA has done over the last few years, they're buying a lot of the kind of operating environment, buying a lot of switch OSs. They bought, Mellanox to get into basically that high bandwidth switching between nodes, and now they bought ARM. Right. So, I mean, it's pretty clear that NVIDIA is positioning itself to be in that CPU market with, Intel and AMD. And one of the most fascinating things I find about this is when you look at the financials of the companies, NVIDIA actually has a larger market cap than both Intel and AMD combined. So it's going to be pretty interesting what's going to happen in this CPU and the server market over the next few years, and see what new entrants are going to be there, and then what kind of merger and acquisition possibilities are actually out there in the marketplace.
Well, point of order, they haven't bought ARM yet. They have offered to buy ARM.
True enough.
Yeah, that's actually a good summary, Jason, of kind of like where we are. And I wonder, John first and then Denny, do you guys want to give us your summary of this question? Is it the end of the server as we know it?
Without a doubt, I think it is. Not only is it the end of the server as we know it, might be the end of the server CPU vendors as we know them. Because if you look at the large guys, they're going towards the O&O, owned and operated chips as well. So the Microsoft of the world with Azure, Google with the Google Cloud, Oracle has Spark, right? But everybody's going to be doing something, and they might not be going towards using a regular CPU. They're going to be using their own CPUs. They'll be highly specialized and delivering the product, the services that they want, and hopefully maybe customizable, configurable, and using AI to tie everything together for specific customers.
Yeah, I think it's going to be a while still, but yeah, I think the server is going to be just dying, if not going to be dead in the next few years. Especially as we have cloud environments from Azure, AWS, GCP. Those are going to be the big three we're going to see, and how we're going to see everything being used and available. And that's a lot of things moving towards these large public clouds. Companies are still going to need some sort of private cloud on-prem, either on-prem or at a colo or something like that. But I see the majority of things going into these large public clouds just because these guys have the capital to be able to do things at absolutely massive scale that you just can't do yourself. You can't do at a small shop. I can't buy 10,000 servers and deploy them. And I certainly can't do it at the cost that one of the big three is able to do it at. So these guys are going to radically drive down the cost of doing things. And as things get cheaper, they're going to be easier and easier for people and companies to be able to do. And I think that's going to be a great thing for the industry as a whole.
Yeah, absolutely. Well, thank you so much, guys. I think that this is absolutely reflective of the way that the industry is heading. And I'm really personally excited that, three people with such diverse backgrounds as the three of you really are seeing similar trends in each area of the industry that you're working in, whether it's, developing, hyper-converged, solutions, developing managed services, or dealing with big data and analytics workloads. All of us are seeing the same trend, which is that everything is getting bigger than the server, everything is busting out of the server, and it doesn't really matter where you look, you'll see it. And, certainly from my perspective as a storage guy, I'm seeing that too. I mean, you look at, what companies like, everybody from like Pure Storage and, Dell EMC all the way to, Scality and people like that. Everybody's scaling beyond the box. And that's good. That's a good architectural trend. And I think it's a trend that's going to continue. So there you have it, folks. It's the end of the server as we know it. And I feel fine. Thank you for listening to the On-Premise IT Roundtable podcast. If you enjoyed this discussion, remember to subscribe, rate, and review the show, since that really does help our visibility. No kidding, it really does. And please share this show with your friends. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to GestaltIT.com/podcast. Thanks, and we'll see you next time.